today, before I give you the review, I want to refresh your brains on two topics, both having to do with right triangles. So the first one we learned was special right triangles. And the two that we consider special are the 45, 45, 90 and the 30, 60, 90. And when we introduced those, we built them off of a square and an equilateral triangle. And we proved why this relationship exists. So with the 45, 45, 90, whatever the length of the legs are, you just multiply that times the square root of 2 to get the length of the hypotenuse. So if we started with the hypotenuse, we just do the inverse of that. We would divide by the square root of 2, inverse operation, to find the legs. Now the second picture is a picture of a 30, 60, 90 right triangle. We got that by dropping down the altitude on an equilateral triangle, and we solved it using the Pythagorean theorem. But this relationship always works with a 30, 60, 90. With the 30, 60, 90, we like to start with a short leg, and we call that short leg x. To find the hypotenuse, we would double that. And to find the long leg, we would take that short leg and multiply times the square root of 3. The short leg is obviously across from the smallest angle, which in a 30, 60, 90 is the 30-degree angle. So the short leg is always across from the 30-degree angle. The 45, 45, 90, 30, 60, 90 are important for this unit because they are going to be used when we start building the unit circle. Okay? All right. Okay, take a minute, write that information down if you need it. Yeah. Well, you're going to notice that math and physics do kind of align well. They do.
It's just algebra though, it's not getting past that.
It will.
Because in AP Physics today, it's like, oh, we don't go past algebra. So you won't see like certain types of graphs. But probably,
Is that the first AP Physics class?
Yeah.
Okay, the second one, you will. Yeah. I'm like, wait, you do. Okay. So now, not all right triangles are special. So what do we use when we don't have one of those special right triangles? We can use right triangle trig and SOHCAHTOA. So SOHCAHTOA is our mnemonic that helps us remember the ratios for sine, cosine, and tangent. So sine of theta. Theta is just a symbol we use for an angle measurement. Sine of theta is equal to the opposite side of the hypotenuse. That's where the SO is in SOHCAHTOA. Cosine of theta is a ratio of the adjacent side to the hypotenuse. That's the cosine of SOHCAHTOA. And tangent of theta is the ratio of the opposite side to the adjacent side. That's the TOA part. And those of you that are in physics, have you used the TOA part?
yes.
Yeah. The tangent does have a lot of application purposes because those measurements are easier to find at times than that hypotenuse. Okay, any questions on just the ratios themselves? All right, so a quick review of how we use them with right triangle trig in this class. All right, so if we have this example 1 here, we have this right triangle. The angle I'm referring to is this 38-degree angle, and you're given one side. So the way you were taught was to look at this triangle and think, or even note on the triangle, what the sides are in relation to the given angle. So this side is the opposite. This side is the adjacent, and this side is the hypotenuse. So if we wanted to solve for x, you look for what you want, and you look for what they gave you. I want x, which is the opposite. They gave me 6, which is the adjacent. Which trig function is a ratio of opposite and adjacent? Tangent. So that's how we would begin. Tangent of 38 degrees is equal to the opposite side over the adjacent side. And then we just solve. So in this case, to solve, it's fairly simple. You just multiply both sides by 6. And when we do, we get 6 times tangent of 38 degrees equals x. Those of you that might be taking the ACT this weekend, your answer could be that. They may not multiply it out. They may just leave it like this. But they might also multiply it out. So if we were to multiply tangent of 38 times 6, very good. Okay? Very good. Okay, now we can set up a similar equation to find y. But to find y, which trig ratio? Cosine. So cosine of 38 is equal to the adjacent over the hypotenuse. So this time I would multiply by y to get it out of the denominator. But then I have to divide by cosine. So that this could be the form of your answer on a standardized test. Or we could go ahead and divide that out and we get y is approximately
7.61.
very good. 7.61. Perfect.
I did the Pythagorean theorem too.
Okay, I would not suggest Pythagorean theorem because if you missed x, let's say your finger just accidentally pushed the wrong button on the calculator,
Okay.
and you use Pythagorean theorem, you're automatically going to miss the y.
Yeah.
So, all right. Now this one, I want to talk about naming sides of a triangle real quick because it was like 6th grade when y'all learned to do that. So to name sides of a triangle, there's 2 ways we could do it. We could use the 2 letters. Okay, 2 letters. 2 letters. All right, I've named all 3 sides. Now, if I was talking about the length of those sides, what would change? This would just go away. Now that stands for length, right? All right, now there's another way to name sides. Another way we could name sides is using the lowercase letter from the angle directly across from it. So this could be side AB or little side C. This could be side BC or it could be called A. And this could be called AC or little b. Okay? So I just wanted to remind you so that little things like that don't trip you up. Okay, and this triangle, you would definitely use Pythagorean theorem to find A. Because anytime you were given 2, you would Pythagorean theorem to find the third. Yes. Now, what if I ask you instead of to find side A, I ask you to find the measure of angle A?
Then you use the inverse.
You do. So, with respect, with regard, whatever word you want to use, to angle A, this side is the adjacent and this side is the, and which trig function would I choose? Very good. So the cosine of A is equal to the 3 over 15. So we would have to use the inverse. And so A, the measure of angle A is approximately
78.4.
very good. 78.46 degrees.
That's a pretty big time.
Wait, would you rather have us use A or theta for that?
In this case, A.
Because it gives you
Yes.
it gives you the all in.
Yes. Yes. And in this case, you were given, use A. If it's named. All right. So that's pretty much it. You have the rest of class to work on the assignment.
Yay!
Yay!